we're going to do some quick rote learning for circuits. So this is just learning, this is no understanding. There's a quiz at the start, a quiz at the end. Let's get it done. We're going to start off with circuit symbols. Now you need to know these, you might want to stop and try and fill in this table for yourself. But let's buzz through it. Cell, big one, short one. I've added a bit more, so this one's the positive, this is the negative. Remember, current goes positive to negative. Terminals, if I've got the ends of something, there we go, like the starts of an end of a switch. Buzzer, easy. Filament lamp, motor, big M. Open switch, as you'd expect. Close switch, I've just closed it. Ammeter, measures current, goes in series. Relay, never really need that one, but it's on there anyway. Battery, lots of cells together. The dotted line means I can have as many cells as possible. Fuse, it's a long thin wire, which remember can melt when too much current goes through it. What's this one? Well, that's the light coming in, that's my resistor, and this means it's a light dependent resistor, or LDR. Semiconductor diode only allows current to go in one direction. That's all we need to know about that. What's this one? Well, again, here's the same as the light. It's light emitting, and it's the diode. See the same in the middle? It's an LED. Variable resistor. Well, how do I show it's variable? I draw a line through it, an arrow, shows I can change it. Resistors as it is, and these couple at the end are kind of odd ones. You don't really need to know them. I've never seen them come up, but they're on there too. There are symbols. Go away and learn them. What's next? Well, people always get muddled up between quantities, the things we measure, the symbols, what we put in the equation to represent them, and the units, what they're measured in. So let's look at one. Power, very important. Symbol P, but we measure it in watts. That's our unit. What about current? Well, symbol is I, oddly, and it's measured in amperes, which we represent with a big A. Voltage or potential difference. Symbol V, that's one of the few ones where they're the same. V for volts, V for the symbol. Energy, well, how do we measure energy? Well, we measure it in joules, but its symbol is E. Okay? Charge, funny one, don't know why, but this one's a Q, and it's measured in coulombs, capital C. And resistance, which is measured in ohms, but has a symbol R. Okay? That's one more time. I put time on here because it's in one of the equations, although it's obviously not just electricity. Symbol T, unit seconds. So how many is that? 3, 6, you already knew time, that's easy. 6 things, go away and learn them, don't get them wrong. Okay, you look very, very silly if you get these wrong, or these ones muddled with these ones. So where do these come in? I said they were in the equations, but first of all we need to know 4 definitions which were also represented by equations. So these definitions link together. We need to know these, and these are the 4 people who get muddled up. Current. Well, we say that's the rate of flow of charge. It's how many coulombs pass a point each second. Resistance is what opposes the flow of charge. So the more resistance, the more opposition, so the harder it is for those electrons to go through, those coulombs of electrons to go through, the bigger the resistance, the smaller the current. Well, what's voltage? This is the one that most people get confused with. Well, if I've got a voltage between 2 points, it's just the energy difference between these 2 points for 1 coulomb. So it's the energy transferred per unit charge. And power is how quickly I'm using energy, so it's the number of joules I use each second. The rate of flow of energy. Brilliant. 4 definitions, really important. We need these. Here's my way of remembering equations. Okay, it's really pants, I'm sorry, but it does help me remember it. First one, rhinoceros is, wow, there's P. I have a needle, I, that's a voltmeter, so I get PIV. I think PIV, easy to remember. Power equals current times voltage. Power is brightness if we're thinking about bulb. It's how much energy I'm transferring to my toaster if it's a toaster. It's the joules I'm using per second. Depends on my current and my voltage. Next one. Can we work it out? V equals I times R. Vrr. The sound you make when you're cold. Very important. Sometimes called Ohm's law. We need to know this one. What's that? It's a Q, it's an I, it's a T. Kit, like a kit car. The charge is equal to the current, number of coulombs per second, times the time. Okay? And what's this one? You might not have seen that movie. If you haven't, you won't get this one. V equals E for energy over Q. The voltage is the energy per unit charge. You see how it links to the definition. You should see how this links together. Last one, my favourite one, this one, vitamin E, E equals V times I times T. Energy equals potential difference times current times time. Last one, we've got our equations, our definitions and our circuit symbols. This is the other thing that people get muddled up with, and it's IV graphs. There are three we need to know, and we need to be able to describe them and identify them. So this is, if I varied the current or the voltage, what type of graph do I get? The positive represents the component in one direction, and the negative if I flip the battery or flip the component. We need to recognise these. So this first one is what we call an ohmic resistor. It means it obeys Ohm's law. Vrr. It's a wire or a resistor. This one is a filament lamp. Why do I have to use the word filament? Because LED is different. So this one is just a bulb, if you want to think about it. And this last one's a diode. So what do I need to know about these other than drawing them? Well, the gradient is 1 over the resistance. So that means if the gradient's high, the resistance is low. And if the gradient is low, the resistance is high. So what do I know about this gradient? Well, can you see that it's the same slope? So that must mean the gradient's the same. It means that the resistance is the same. Okay? Very important. This one, what's happening to the gradient? Let's look at this positive bit. The gradient's going down. And by this equation, it means the resistance, therefore, must be going up. Well, why is it doing that? Because when I get more current, the electrons transfer more of their energy and the temperature goes up. So that's explaining. You could be asked to explain that graph. And finally, this diode, it only allows current to flow in one direction, which is why it's got an arrow. In this direction, the resistance is really, really high, so there's no current allowed to flow. That's it. Go away and look at the quiz. Go back and pause this, make some flashcards, learn that stuff. Good luck.